Alright, there's a video for 3HT about exercise 43 from chapter 7. Now, this exercise is kind of difficult. It also has a B in front of it. That means it's already a bit more difficult than the other questions. But I'm going to walk you through this exercise step by step. And then hopefully as many people as possible understand it. Also, this video is about 47, which I'm going to explain after it. Now, first we're going to take a look at this. It says Henry is standing on top of a 28.5 meter high tower. This is the tower. And his eyes are 1.8 meters above his feet. So here you can see where his eyes are. Now when he looks from the tower, he sees this river with an angle of 8.3 degrees. And we need to calculate how wide is this river. Alright, so to tell you how to do that, we need to calculate how long the distance is from the end of the river until the tower. We need to calculate that length. Because then if you subtract the 18 meters that you see here, then you know what this is. Alright, so we're going to take a look at this triangle. Right? And we already know this length. Actually, this is 28.5. If you add 1.8 to it, you know the whole length. Right? So the whole length from here to there, that whole length is when you add this. So you get 30.3. So that's that length. Now we know that this angle is 8.3 degrees. But if I want to calculate this length, I need to know the whole angle. Right? So what we need to do first we need to calculate how much this angle is. And then we're going to add this to it. And then if you have that, then you know how big this whole angle is. And then we can calculate that length. So there are a couple of different steps that we need to take. So first we're going to calculate what this angle is here. So this length is 18. And this length, we just calculated that. That's 30.3. So if I want to calculate this angle over here, then I need to do the following thing, right? I need to do the tangent minus 1 because we calculate an angle. And then the opposite side, which is 18, divided by the adjacent side, which is 30.3. Now if you calculate that, you get 30.7 degrees. So that's this angle. This is 30.7 degrees. I want to know that whole angle. So that means I have to do this 30.7 plus the 8.3. And then you get 39 degrees. So this whole angle, so that one is 39 degrees, right? This line means the whole angle, and the whole angle is 39 degrees. So with that, and with this length, we can now calculate how big that length is. So I know that the tangent, we're going to calculate the side now, so that means I just use the normal tangent, right? The tangent of this angle, the angle is 39, is the opposite side. Well, the opposite side, I don't know, right? I know that this part is 18, but I don't know that part, so I don't know what this length is. Question mark. It also doesn't have any letters, but if you want, you can put letters in it, right? But this is the opposite side that we don't know, divided by the adjacent side, which is 30.3. So if you do 30.3 times the tangent of 39, if you calculate that, then you get the answer, which is, actually you get this whole length, which is 24.54 meters. And then what we need to do is we need to subtract this 18 from it, and then we know how wide the river is. So 24.54 minus 18 equals, well, rounded off to one decimal place. I'm going to round off at 6.5 meters. Yeah, so you see, it's a very complicated exercise. You have to do 1, 2, 3, 4, 5 steps, but hopefully you could figure it all out, right? Otherwise, it is a more advanced exercise. So if there are some people that don't understand it at all, then yeah, I mean, that's normal, really. So we're going to go to 47 now. 47 is not a more difficult exercise, but 47 uses a few things that we also learned earlier, like the Pythagorean theorem, and also here you can use something that you learned in chapter 2, and then you learned something about similar triangles, right? You have to make a ratio table and all of that. So first we're going to take a look at this one. We need to calculate BC. So for BC, we just use the Pythagorean theorem. So BC equals the square root of 3 squared plus 2 squared. Now you can just type it into your calculator, and there you get 3.61. And that's the answer for BC. Then for exercise B, or this exercise, triangle KLM, we need to calculate LM. So then we use the tangent, the sine, or the cosine. The one you want to calculate is the hypotenuse, and the one you already know is the adjacent side, because we're going to use this angle, right? This is the adjacent side for that angle. Adjacent and hypotenuse means that we have to use the cosine. So the cosine of 58 is the adjacent side, 2 divided by the hypotenuse that we don't know. So 2 divided by the cosine of 58, if you type that into your calculator, then you will get 3.77. And that's the answer for this triangle. And then for this one, we need to calculate QR. Now QR is this length from here to over there. So we're going to use similar triangles. Here's a small repetition of what you learned with chapter 2. All right, first I'm going to say that triangle RPQ is similar to triangle RTS. This is triangle RTS. So we're going to make a ratio table. In triangle RPQ, I know that this length is 2, right? So PQ is 2. This length is 2. And in the small triangle, we have ST, which is 1.5. Then in the big triangle, we have this length QR that we don't know. And in the small triangle, we have RS, which is 3. And if you want to calculate the missing number, in this case, that's QR, then you need to do the cross products. You have to do 3 times 2, right? And then divided by 1.5. So 2 times 3 divided by 1.5. Well, this is 6. 6 divided by 1.5 is 4. So then you know that QR is 4. So here's Pythagorean theorem that you learned in the second class. Cosine and tangent sine that you learned in chapter 7. And something that you learned in chapter 2. And you're going to need this with the coming exercises because they're going to combine all of these three things. So that's going to be a bit difficult. But thank you for watching this video, and I'll see you later. Bye-bye.